Good afternoon, everyone. From here in the UK, good morning to those in the US, and good evening to everyone else in Asia and the rest of the world. This is a panel that's being established by GSOA, the Global Satellite Operators Association, bringing together myself and some experts from the space sector to talk about interoperable digital standards. Is now the right time to be implementing these standards? And today we're going to focus on a particular technology for digital interfacing between infrastructure. And as we know, the standards are crucial towards the telecom sector, and they've generated growth across the whole of the mobile and telecommunications sector, including satellites, where we have the interoperability between gateways and satellites and terminals using DVB and 3GPP standards. What we're seeing right now in the terrestrial standards is the adoption of interfaces that allow for new architectures to be exploited, for new entrants to participate in the delivery of capability, standards like CIFRI under Open RAN. And what we'll do today is we'll explore the potential exploitation of new standards for interconnection between different aspects of ground segment for the satellite communications world, and how these might eventually develop and be taken forwards, potentially with the opportunity to exploit them for other aspects of satellite systems. So I have a set of the panelists today. So I'm Paul Fevra. I work at the Satellite Applications Catapult in the UK. I've been involved in satellite communication systems for about 40 years, so I've seen an enormous change over that time. I was working at Inmarsat, procuring or specifying procuring satellite systems as an operator for about 20 years before I joined the Catapult. And right now we're seeing this revolution take place. So I'm going to introduce the panelists, including Stuart Davies from Kratos, who is the chair of the Diffie standard, Mark Dale from Comtech, well-known supplier of capabilities for ground segment, Dr. Ryan Stevenson from Kymeta, creating innovative antenna solutions, and Dr. Gavin Cox from Global Infocom, who've been instrumental in producing things like set-top boxes and very familiar with the value of standards. So perhaps I could ask each of the panelists to introduce themselves now, starting with Stuart and his relationship to the standard and why he thinks it's valuable in his own organization. Welcome, Stuart.
Thank you. As Paul said, I'm Stuart Davies. I work for Kratos. I'm their Vice President of Advanced Technology, and I'm also the Chairman of the Board for the DIFI consortium. And just to give a quick background, Kratos, we focus on satellite ground systems, and one of the big things that we see in the industry is that the industry is moving from analog infrastructure to digital infrastructure, and will need to in the future. And this is one of the reasons why we were very excited to help form the Diffie organization, because we saw a gap in the market where if there wasn't an interoperable standard at the digital IF level, it would stop the adoption of digital systems. It would slow down the adoption of digital capabilities in the satellite industry. And so that was really the issue that we were trying to address with the formation of the Diffie organization. And fortunately, it was something that a lot of people in the industry were interested in and wanted to address. We got particularly a lot of support from the US government, US military, because they saw similar issues. And so that's what led to the formation of the organization.
Thanks, Stuart. Mark, do you want to add your introductions and say a bit about Comtech and your involvement?
Sure. I'm a corporate BD guy for Comtech, and Comtech as a company is very interested in producing products that comply with this standard. We believe that digital IF will be the next ubiquitous standard for signal distribution, just like 70 megahertz IFs gave way to L-band. We believe that L-band interfaces will give way to digital ones that add a lot of flexibility, lower cost, and higher performance, and we hope to be introducing products to support that, and along with a lot of the other people in the panel here and a lot of other people in the industry. So we're keenly interested in this standard and supporting it.
Thanks, Mark. Ryan, would you like to say a little bit about Kymeta's involvement?
Yeah, thanks, Paul. Yeah, so I'm chief scientist for Kymeta, and I'm also a member of the Diffie board of directors, representing Kymeta there. As you mentioned in the intro, Paul, Kymeta is about advanced antenna systems for mobility applications. And one of the things that we like to, one of the reasons we're supporting the Diffie consortium and the Diffie standard is in legacy satellite communications with proprietary systems. Very difficult to implement advanced antenna terminal designs that incorporate novel approaches like what you see coming to the market now, multi-beam, multi-orbit solutions. An example of this is our hybrid GEO-LEO satellite terminal, where today we have to put multiple modems into this terminal product. What we would like to be able to do with the Diffie standard implemented in the future is be able to virtualize that and make it a lot easier for users to adopt.
Thanks, Ryan. Gavin, would you like to say something about Global Infocom's involvement?
Yeah, good afternoon. So I'm Gavin Cox. I'm the R&D engineering manager at Global Infocom. Global Infocom are a company that design and manufacture both terminal and gateway antenna systems and the associated ground equipment such as transceivers. And from our side, anything that allows the interoperability and the ability to use multiple equipment without vendor lock-in, etc., is obviously something that we're looking to support and provide solutions for in our equipment. And secondary to that, along with Mark, who I think has just disappeared from the call, I co-chair the technology working group, which is one of the working groups through GSOA that was originally formed from the mutual recognition working group at the GVF. And through that, we are looking at ways that type approvals and equipment certification can be standardized. So open standards and initiatives like Diffie lend itself to that. And as the remit of the working group has expanded to include terminals, then Diffie starts falling into that sphere.
Oh, thanks, Gavin. Well, hopefully we'll be able to explore some of that today, and well, equally, hopefully, I hope Mark will join us again shortly. But maybe to set some context, Stuart, it'd be quite nice if you could give some bit of a background, not only the purpose, which I think is you've already started to do that, but a bit about where we are in the process. You've mentioned the defence, UK, US DoD interest in this. Perhaps you give some context about the reason for the standards in terms of operator flexibility and that sort of thing from your perspective. How do you see it spanning out?
Sure. So I think why now is the time for Diffie, and you'll see virtualization and a digital transformation in general for the industry. It all goes back to the fact that the industry is switching away from broadcast and moving to focus on IP transport. And once you start doing that and realize that the future is IP transport, this has led to the changes in satellite architectures, moving from FSS architectures to HTS architectures to software-defined satellites, to an enormous amount of flexibility and enormous amount of capability or capacity into these HTS satellites. And so as a result, what happens is, in the legacy systems, why we ended up with proprietary standards or proprietary systems was efficiency. Bandwidth efficiency was the most important thing. And squeezing out an extra 2.2 dB of performance was critical. And it was worth buying a proprietary system to get that extra performance. As you look at the future HTS satellites, now all of a sudden you have 10, 20, 50, 100 times the bandwidth of a legacy FSS satellite. That bandwidth efficiency isn't quite as important as it was. It's still important, but not quite as important. What's now important is scale. the ability to scale your services. And to do that, that's where standards really help. And that's where moving from analog to digital so that you can automate your operation really helps. And so, but the first step in that is moving to a digital IF infrastructure. And so what we saw is that there is without a standard at the digital IF level, you'd immediately have vendor lock at the digital IF level, whoever provided the digitizer. And we knew the industry wouldn't allow that. And so that you had to create a way to get interoperability at that level. And so that's really how the Diffie got formed, where the military sees this is they have a scalability problem at the IF level. Their gateways, with their WGS satellites, expanding that system and the capabilities of those satellites, they're running at the IF level problems where they just can't build big enough matrix switches. And so they realized that digital IF was their need for the future to be able to scale up to the level of systems they wanted. And so they were very excited and very supportive of an industry-led digital IF standard. And they literally were instrumental in helping us form the organization.
Thanks, Stuart. Do you see that there's also a role in here with the standards with regard to handling the additional complexity of the ground segment infrastructure, the resilience that might be required to satisfy multiple satellites with multiple feeder links, etc.?
Absolutely. I mean, again, as we move to becoming, an industry that supports IP transport more than broadcast, we end up just becoming an extension of the telecommunications industry. And, we need to have the architectures and flexibility that they, implement and to be able to support that same flexibility in our architectures, because the future isn't, standalone networks anymore. The future is, integrated networks where the future, where you're sending data over the best available path, whether that be LEO, MEO, GEO, because latency is the most important thing, or cost is the most important thing with that service. And so to get that level of flexibility is very difficult in a hardware implementation. And that's why the terrestrial world moved to software, virtualized infrastructure. And that's why the satellite industry needs to move there to match and integrate with the terrestrial industry.
Well, thanks, Stuart. And just in time, Mark, you're back to answer the question. I think from the perspective of the infrastructure in the ground segment, the modem fabric, etc., and the connectivity requirements that we've got. Can you say something about the value you see in terms of how these standards can facilitate the capability of deployment from an operator perspective, flexibility in terms of the functionality and efficiency of the ground segment?
Sure. I mean, I think that Diffie, the core value of Diffie, obviously inherently, it's to enable a more efficient and higher fidelity signal distribution. And that really enables a lot of applications. I mean, for example, the government is very keen on resilient SATCOM, where they can route various signals through various places. And increases the capacity and the resilience to things like jamming and other service denials. And so that something like Diffie is essential to support that. There's a lot of other applications too. I mean, advanced applications, say signal interference, excision, beamforming and things like that, which is already mentioned, and which is really facilitated by the standard, and is very, very difficult to do without digital means. So, those future applications, I think, are going to be some of the key drivers for adoption of Diffie standard moving forward.
Do any of the panelists therefore think the sort of applications to LEO systems in the future, what the potential value of Diffie will be with regard to ground segment architectures for some of the constellation systems that are being deployed?
Yeah, I can jump in there from the user terminal perspective. I think Stuart touched on this a little bit too, but we're looking towards applications that span hybrid network architectures that would include LEO, MEO, GEO, and being able to rapidly adapt your network solution seamlessly transition between waveforms, orbits, constellations, and to do so with a user terminal that also has that kind of flexibility. So you're not burdening the design of the user terminal with something that someone can't buy or easily use. It's sort of like hitting the easy button, right? Yeah, the Diffie standard, or a digital interoperable standard, is going to facilitate all of that, and it's happening now. It's not sort of a future thing. That's right on us.
I mean, I think one of the challenges here, of course, when you're talking about operating with GEOs, LEOs, and MEOs, from a ground segment perspective, is the ground segment infrastructure is somewhat different in each of these cases. Link budgets are going to be different, so the infrastructure will be, different for those different systems. And I guess there's some consideration with regard to interoperability from a ground segment perspective. But I know from the work that I've done historically, when we've been building systems for Inmarsat, we would be considering those systems to be essentially Inmarsat owned and operated. We would be hosting the infrastructure in certain ground segments around the world, but we wouldn't necessarily dictate the particular technologies that would be used to, for instance, to connect the antennas to the racks of equipment, and that would be the integrator that would provide this. Do you think this is changing now, and what you expect is operators, when they're specifying the systems, will be looking to perhaps mandate open standards or these interoperable standards for different parts of the infrastructure to allow for essentially generational shift or for flexibility?
Yeah, I mean, I'll step in here. So, and I think the industry is being disrupted by some of the newer entrants with their sort of vertically integrated and closed supply chain models. So I think the established operators are having to adapt their strategies to accommodate that, and in response to that. So I mean, in that context, increasing sort of the calls for ground segment to innovate and drive innovation in the ecosystem to bring costs down is going to be one of the things that's needed for competitiveness. And for that, for us, the adoption of open standards and the ability to have the interoperability within that ground segment is one way that will be achieved.
Okay, that's excellent. And in terms of actually moving from one generation of satellites to another, maybe moving from one generation of ground segment to another, what are the challenges that the operators might face with regard to adopting the new standards and making it part of their roadmap? Is that something you can touch on, Stuart or Mark?
Sure. Before I touch on that, one comment on the last set of questions is it's worth noting that that there are parts of the satellite market that have already totally adopted the Diffie standard, and that would be like the Earth observation market for TT&C and mission download. If you look at those systems, they have gone digital, where they digitize close to the antenna. They do software-based modems behind it, and the manufacturer of the digitizer and the manufacturer of the software modem behind it are often different companies. And this has enabled that the ground as a service business model that you see in that market, whether it be KSAT or Atlas or Microsoft and Amazon jumping into that market, it's enabled that ground as a service capability because they've gone with standards, and now they can get modems from multiple different vendors by doing this. And so you're seeing the standard already applied in that part of the market, and they did it because they needed to get the cost of the ground system down, because the cost of the satellites with new space and small sats were dropping rapidly. You couldn't have ground systems at the same price points that they were. So I think that's a critical thing on the last point.
And how do you think that will translate to the telecommunications sector as we move from broadcast to broadband, for instance?
Well, I think
I think you'll see.
Go ahead, sir.
No, go ahead, Mark.
Oh, I think what you'll see is not maybe so much people dictating standards. People will adopt it because it drives cost and it allows an open architecture. I think just what Stuart just mentioned. I mean, there was a drive there because now people can do new things. They can buy things from different companies. They can offer things as a service and whatnot in the TT&C market. I think you'll see the same thing in the broadband market. I mean, there really is, or at least there has been for service operators, a de facto standard. And L-band interfaces are very similar to each other. And I think that as Diffie takes over for these things, and you have a lot of products in the broadband market now, I think some of the offerings in the TT&C market are already cost competitive. I think in the broadband market, they need to get there. And I think you'll see in the future a lot of broadband satellite, two-way satellite kind of markets where Diffie could offer the same kind of compelling solutions that you see in the TT&C market now. And so I think it'll be driven for not so much a top down the operators mandating it, more of a bottom up. We'll have to give them a reason to adopt the standard, and that'll be a cost and functionality type of thing.
I understand. I think one of the things that's happening in the cellular sector or the mobile sector now is the intent to create diversification in the supply chain and look at new open architectures and standards for interconnections for the concentrator units and distribution units and like. So, and given that in mind and the current focus of the sector on how do we support integration of satellites into terrestrial networks in the future, did you see that there's any overlap and value of integrating the Diffie with other standards in the terrestrial cellular domain, or such as CPRI and the like, and the relationship between them? What's likely to be the future with regard to terrestrial satellite integration and the application of these standards?
I can take that one. So in the near term, I think most systems will not integrate at the digital IF level. It'll happen either at the IP level or at the RF layer. And as a result, eCPRI and Diffie will just coexist, and you'll either be using one or the other. There is a chance in the future that you might need to support both longer term as systems integrate tighter and tighter, but I think that's pretty far off. And the good news is Diffie, works just fine with 5G based signals and networks, and so it's compatible. So it doesn't impact you if you want to go to 5G. There's no negative hit by not using eCPRI, and so I think it actually will help adoption because again it makes our infrastructure, the SATCOM infrastructure, have similar capabilities as the telecom infrastructure. And so now you can start, I think it's really the layer 2 where you're going to start seeing integration with, where you're going to see satellite systems start integrating like with MEF and 5G and other terrestrial standards, that where it really going to have a big impact to allow SATCOM to integrate more tightly with telecoms services.
Oh, thanks, Stuart. That's really clear. With regard to
just picking up on one of the things that you drew parallels between satellite and the mobile space. Now, things like Open RAN, my understanding is that those were being driven by the actual operators themselves. Whereas to Mark's point, it sounded like he was suggesting that the drive towards the standards in the satellite sector would be coming ground up from sort of the integrators and that sort of thing. So there are differences, I think, between the two ecosystems in how they're adopting this sort of thing.
Any comments from Ryan or Mark on that?
Well, I think it would probably be a combination. Some people will want to just mandate it because they're looking to the future and they want be able to replace gear and want interoperability between different people. I think that right now the state of the industry really is people, at least in the broadband world, they'd have a little hard time doing that because I think a lot of and this is one of the obstacles that we in some of the companies on this call are going to have to address and overcome. Other companies in the industry as well. It's just to be able to provide a rich mix of products that people can use. And I think that's the I think once we get there, and I think that's coming. I mean, that's coming in the near future. Then that kind of then it can be informally adopted just because everyone supports it. And you would buy a product that wouldn't support it, or maybe formally mandated as well. So it might be a mix of both kind of approaches.
So Stuart, go ahead.
I would just add to that there is a user push for it, and it's really coming out of the U.S. military. Like the Army has specified Diffie in a couple of recent RFPs, and that they're the biggest buyer of SATCOM capacity in the world. So when they say they like Diffie and they're interested in having it implemented, the vendor community takes notice. And so there has been absolutely some end user push. It's been more though out of the government markets than I'd say the commercial market, because I think they're seeing they have nearer term scale issues more so than the commercial industry today. And so they're just seeing the problem sooner.
Yeah, just to add on to what you're saying there, Stuart. I think US DoD operates well over what is it, 150 different kinds of SATCOM terminals. For them, it's a huge logistics footprint to manage and maintain all of that. So a digital standard, interoperability standard, simplifies their life considerably, and we see that same push coming from that user base.
Yeah, I'll second or third that, I guess. Certainly the Army is a big customer, and the DoD in general, and we see that as well. So I mean, the Army has recently procured modems that have this capability and operate with this standard, and I think that they're looking to build out, as Stuart was saying, they're looking to build out a next generation digital ground infrastructure, and that's going to benefit them. To do that, and people like to say we'll build, as Stuart was saying Comtech will be among them. We'll build products to support that.
And I guess we've got this aspect now of definitely we have interoperability. There's already deployments, so do you anticipate that maybe what we'll see is a kind of globalization of the standard and adoption by other organizations, and maybe their institutional organizations to start with similar challenges across the globe? Will that be one of the ways we see this technology become more ubiquitous?
I think so, but I also think it's really going to be as the vendor community, the user community will start specifying it when there's enough of the vendor community supporting it. And so it's a little bit of a catch-22. The great thing about the U.S. military is they're willing to push a little ahead of the game, because they know they have the leverage that they can. And so but I think if we see that happen, I think you'll see the rest of the industry come, because they need to. I mean, they know they got to get to be able to support the scale of their future satellites and their future networks, and they got to drive down the cost of the ground systems, and that comes by moving away from purpose-built hardware and moving to virtualized infrastructure. And that step one in that is moving to a digital IF infrastructure.
Thanks, Stuart. I mean, I'd like to just explore what the implications might be for new markets as well. One of the challenges we face if you're a customer of satellite services is potentially, the desire to move from one space segment provider or service provider to another. And the ability to maybe repurpose your infrastructure. Any thoughts on what it means from an end user perspective, perhaps more commercial, or maybe there's a government services aspect there as well, from the potential exploitation of the standards or derivation of the standards, Ryan or Gavin, maybe, or even anyone really, with regard to the benefits it brings to an end user in terms of being able to operate with multiple service providers.
Yeah, I think that from our perspective as a ground equipment manufacturer, the move towards software-defined radios within the hardware that we're providing that would allow configurability for whether it's L-band, S-band as an IF, and as services get migrated, then there may be changes in those aspects of the system. The ability to configure that and provide the output as a common IP stream is massive. It means that there isn't a requirement now to go and replace terminals in the field. It can be, configuration can be done over the air, and it's a seamless changeover to services.
Yeah, I would say it's very similar on the user segment side as well to what you said, Gavin. It's about seamless transition, like I said earlier, across multiple constellations, multiple waveforms. And shortly here, as we see these advanced antenna systems roll out that can do multi-band, multi-beam, multi-orbit. I'm reflecting on the U.S. Space Force white paper from a couple of years ago that called out their super dream of what the end-all be-all of a SATCOM terminal would look like. On the user segment, the digital interoperability just facilitates that. And whether it's a commercial application or a government services application, I think from a hybrid networks perspective, even rolling in the terrestrial side, and having Diffie be able to cooperate very well with 5G standards, that's something that Kymeta is doing right now. But it's sort of in this sort of kludgy way, because we have all these modems in our terminal, and we would like to be able to implement software-defined architectures like Gavin was talking about, and be able to virtualize all those functions. And I think that just, it hits the easy button.
Ryan, Kymeta's.
I'll reiterate.
Sorry, Stuart. I'll just go ahead if you want to add something.
I was just going to reiterate what Gavin and Ryan said. It enables that multi-mission terminal that everyone wants, and really enables the value that these flat panel antennas that are under development with just incredible capabilities. If you have to stick hardware modems behind it, it just limits the value of them. But if you can virtualize that back end, it gives them incredible capabilities, not only just initially, but in the fact that you can update them and repurpose them with a software load. It's just operationally game changing versus having to mail out, ship out new modems, things like that, if you want to repurpose. It's truly game changing what it will enable.
So I mean, maybe that's something to touch on, whether it opens up new markets as well. I guess, Ryan, Kymeta's current product portfolio, primarily, the high-end markets, enterprise markets, and the like, aviation and maritime. Do you see this as being essentially applicable to these kind of markets? And are there any other markets that perhaps these technologies can be used to help penetrate?
I think absolutely. And actually, I can actually tie that back first to the comment Stuart just made. Our military focused product, sorry, this might sound like a plug, but the Osprey terminal, it has a lower modem chassis on it because the user oftentimes is having to swap modems out. So we have this tray so they can swap a new modem in and plug it in. So that physical modem swap that Stuart was just talking about, which is very limiting in a commercial sense, right? And especially if you're trying to drive down your cost curve to penetrate broader consumer markets. And so having a digital standard that would then go hand in hand with software-defined architectures. So we'll need the software-defined modem, to really make this work. But then that becomes something very reconfigurable. And from the perspective of lowering costs and going into larger, more consumer markets, the ability to just software reconfigure it is hugely powerful.
One of the things I think Diffie, is and this is one of the strengths of Diffie is I think it's sometimes people conflate hardware versus software processing with Diffie, and they really are two different things. It really is just sending. Diffie is about digitizing the RF signal and sending it around, and then whether or not it's cost effective to do it in software or just in firmware is really a trade-off for the application. So I think there's some aspects like Ryan was just talking about, where if you really did have the right software only implementation, then you'd really have something. Something valuable. There's a lot, currently there's a lot of roadblocks I don't know if the software in the broadband world, for high-speed broadband world, for highly dense kind of applications, I don't know if software applications are quite there yet, but in whether they get there or not is really almost irrelevant for the Diffie standard, because, that's a trade-off then, whoever has the best solution, being it, first future software or integrated firmware, Diffie still has value in either case.
Anyone want to comment on, as well as these price drivers, what we would need to see in order for the price to become truly at the price point that actually mass market propositions might be a reality?
You mean a cost point for the Diffie function itself, or cost for it? Oh, well, this is one of these things that I think now where I'm sure it'll get lower as a time. That was one of the, Diffie has actually been around. We're talking this standard panel now, and sometimes maybe implying that this is something new. It actually isn't new at all. I mean, the Army, and Stuart was talking about now that the Army is one of the big customers of driving this. There's no coincidence. That's not coincidental. I mean, the Army actually founded this idea more than 10 years ago. And drove it, and were really responsible for creating it. They really were. A lot of times it's industry is the innovation, and the government picks up. Well, in this case, the government was the integrator, and industry had to pick up from them. But why it didn't catch on 10 years ago was that the technology just wasn't ready. It was way too cost effective, and it wasn't. And now it really has, and it'll continue to do that. So I think it'll get to the point where now L-band, the actual L-band tuners are a few $100s now on a modem. The cost of them, and in the Diffie components on a per thing will be a lot less than that. I mean, I think they're already cost effective for broadband applications. They'll get more cost effective as time goes on. So I think we've already crossed that threshold, and it'll continue to be more compelling as time goes on.
Cool. And what about the roadmap for Diffie moving forwards in terms of its improved capabilities and performance, as well as the kind of scale up of the manufacturing and production price point? Any perspectives on where we're taking the standards and what can be used for? What were the drivers for that?
Sure, I'll start. I think the key thing right now that we're looking at is there's two areas. One, we're looking at different use cases. Diffie can work for all use cases, but it's not optimized for all use cases. And so now we're going back and taking a look at different specific use cases and optimizing for it. For example, in the next release, we just released 1.2. The 1.3 release, one of the things we're looking at is some of the MFTDMA capabilities and some of the things we could do to the Diffie standard to allow it to work more efficiently with those type of systems. And so that's what we're looking at in the next release. But those are the types of things we're looking at. The standard is how to make it way more efficient. The other thing that we're doing right now is going through the process of putting together a certification program for the vendor community, so that whether it be self-certification or third-party certification, so that the end user community can be confident that if a unit's certified, it will actually interoperate with the other certified products. And so we think those are two critical steps. And if you look at any standard, that optimization and improvement process is just an ongoing thing that goes. They're still doing updates to 5G. What are they working on? Release 18 now, I think. And that's just an ongoing process, and the certification process, once it's in place, will then need to track the release process.
Yeah, and
sorry, I was going to say the certification side of things. I think that's something that GSOA, and through the working group that was part of the GVF, has a very strong track record of, in terms of the type approvals and certification through initiatives like SOMAP, which got all the satellite operators together for a unified sort of approval, really. And ways that those sort of self-certifications or witness certifications can be overseen and made accessible are things that, as an organisation and a working group, we are looking at, and what options we can do to work with the Diffie certification group to see how that can be facilitated.
I think that's very important. I mean, in the early days of the IEEE standards for wireless LAN, it was only when the Wi-Fi branding came out and the alliance to actually do Wi-Fi alliance to do the interoperability testing that we saw a lot of the challenges from a consumer adoption perspective being really addressed, because then you can basically plug and play from one vendor's bit of kit to another. And I guess the value of this of the Diffie alliance is to create those kind of constructs, not only the standards but the interoperability test bed and shakedown. From the perspective of where we go in the future and the potential applicability to more consumer mass market products, is this something that we'd anticipate to occur within the next few years?
I think from our side, very much so. We are already being approached about how we can integrate, I'll call it Diffie, a Diffie board into some of our products. So those conversations have started. So it's the sort of technology I think we'll start filtering out in the next sort of probably. I don't want to give a timeline, but yeah, we'll start filtering out and becoming more ubiquitous in sort of the equipment as it's sold and deployed.
So what about new members of the alliance, and how would organizations get involved? Do you see this as being something that is continuously growing and developing, and will have new stakeholders coming in, either customers and or equipment providers?
Yeah, we're still seeing people and member organizations join Diffie on a fairly regular basis. An interesting one that just joined recently was NATO. They joined in the last couple of weeks as new members, and so I think we'll continue to see people join, and mainly because I think what they'll join for is to make sure that their use cases and the situations, their use cases are addressed in future standard, to make sure that it can be implemented and executed as efficiently as possible. So yeah, I think we'll see some continued growth in that area. And I think the other thing is Diffie looking for other areas where we can help as an organization advance the digital transformation of the industry through standards. And so I think you'll see us grow into some other areas as an organization over time.
I think just building on that as well, I would say that as a working group, we are always looking for people who are keen to join, either individuals or organisations that want to be represented, to sort of broaden our outreach and outlook. So I think when this recording gets sent out, I think if we can put the sort of links to some of those email addresses and the contact details to allow people to explore that possibility, that would be helpful.
Okay, that's excellent. So I'm getting some questions or a couple of questions from people around the world. One of the questions are purely technical. We've touched on efficiency a few times, but there was questions about really, can we be very specific about that? Are we talking about spectral efficiency or cost efficiencies, or efficiency of the use of the infrastructure? So perhaps you can just elaborate from a technical perspective when you talk about efficiencies.
Right. When I talk about efficiencies, anyway, I'm really talking about the efficiency of being able to distribute easily signals and whatnot. Spectral efficiency is not impacted by this. It's just a transport mechanism. That's part of the modem itself. So really, it's really the cost and the flexibility and the benefits of being able to much more easily distribute signals, through an infrastructure, and that's really what Diffie is. It helps the efficiency.
So touching on the increased bandwidth, like high throughput satellites, actually looking to 250 megahertz transponders, maybe 500 megahertz and beyond. the potential for Diffie to actually support these kind of increasing capacity of these systems? Is that something that's attainable and even now?
That is a drawback. In fact, one of the things that we talk, in this panel is all supporting Diffie. We only talk about the plus, the upsides of it. One of the limitations of Diffie, or at least of the challenges of Diffie, is when you sample signals, the bandwidth across the Ethernet networks themselves, is much greater than it is for the demodulated signal. And so there's some variants of things where there's just sending demodulated data on these things. But now we're getting down to the technical weeds a little bit. But that's something that from a network perspective, you got to address. And Ethernet networks are getting high capacity. Ethernet networks are getting more common and more ubiquitous, and a lot of applications can be supported. But there is an important limitation there, and we have to address that, and we have to make sure that people understand that. Because otherwise, people, if they're not thinking that. Then when they realize that's the case, that's a requirement, then their expectations are not met. And so we just need from a technical standpoint to make sure people understand that.
I have to say though, Mark, wiring IF feeds and switch fabrics around even on a local site can be a bit challenging. And if you're going to get an optical feed or a gigabit Ethernet feed, then that feels like something that actually is a plus side.
Oh no, there's no doubt about it. I mean, I think that there are challenges that can be overcome. It's a lot easier, like you say, to wire an Ethernet network than it is to an analog switch network, for example, and routing and changing and things like that. But there is, you just have to understand that the technical changing when we get down into the weeds of these things, we just want to make sure that we understand what the requirements really are for it.
Cool. So I've got another question from it's actually from David Gurud in the UK, asking about some of the legacy systems, the fact that there's 4 million broadband direct-to-home SATCOM terminals, Hughes, Viasat, and increasingly now with these mobile systems like the LEO systems like Starlink. Do any of these organizations currently adopt Diffie, or are they planning to do so? If you know of any the roadmap in terms of the mainstream players for broadband systems today?
So
I'm not aware. No, please, Stuart, go ahead.
What I would say is on most legacy systems, unless they have dynamic requirements or scale problems, they're not going to switch to a digital infrastructure because they don't need to. The analog infrastructure they have supports their needs, and it works. Where you're going to start seeing where you want to switch to a digital infrastructure where it's going to add real value. And that's when you start getting into dynamic networks or scale problems where analog systems just become cumbersome to be able to support and implement. And so I don't see a lot of legacy systems switching over necessarily, but I see a lot of the newer systems that are coming out that have, just massive amounts of bandwidth, absolutely moving to a digital infrastructure because they can then automate and support the scale issues that they're going to have. And so there might be some legacy systems that have the value to switch over, but I think in general, it's really the newer systems that are really focused on the IP transport market.
Okay.
And I'll even add, for some customers that like the Army who are really deploying this now, I think what you'll see, for these kind of customers is that they have a lot of legacy products. So as the industry develops products, for them for digital IF products, we have to show and develop products that where they can continue to support their legacy infrastructure and have the digital infrastructure as an addition to that. And there has to be a way to have a seamless transport. There are many ways to do that with Diffie architectures. Again, we won't dive down into the weeds here or whatnot, but even even in these advanced customers like the Army that have legacy systems, they'll have that need, to continue to have it be a seamless transition and not an abrupt transition because it's difficult to do that.
Yeah, understood. And in fact, one of the questions in the chat relates to sort of perhaps a little bit more further into the distant future with regard to homogeneity between terrestrial and satellite systems, and perhaps the architectures that we're going to need for future satellite systems for 5G, for instance, and what the relevance of this technology might be when we have perhaps satellites with got functionality on board, RAN functionality on board themselves, as opposed to bent pipe type architectures. and how the technology might be applicable either for future ground segment or even potentially future space segment. Any thoughts on that kind of question?
I think there'll be a mix. I mean, in some of these really highly integrated systems, for example, whether or not your cell phone, in some future 5G thing where we're talking about extending satellites to standard cell phones, whether or not that digital IF is eventually used inside your cell phone will be kind of transparent to the user. It may be, but where you actually see it is kind of in the gateway infrastructure side, and be able to just be a piece of it. I mean, if you're you won't be ubiquitous if you're doing a lot of processing on the satellite or whatnot. Again, maybe that's just something will come into play. But whenever signals are need to be distributed around from various places, from one place to the other, I think you'll see digital IF being part of that mix.
Oh, that's really fascinating. Thanks. I'm sure we'll be taking that into account in some of the future concepts. So we've got a few minutes left. Just maybe if all the panelists just want to give us a sense of where we are, where the future is, and an invite, what would you like to see happen next in terms of operators or technology providers coming to work with the DIFI standards organization and taking this forwards?
Yeah, I'll go first. I think our future vision is one where we have a very hybrid network architecture that spans LEO, MEO, GEO, and terrestrial as well. And from the user terminal perspective, with the digital IF and virtualization, that enables that. But what we would also like to see from a technology on the user terminal side is a software-defined modem and compute architecture that can then implement this efficiently on the user terminal. It's a little bit different in the hub side, where you can have very large A to D and D to A in very large compute, in a server kind of situation. But we need to see that kind of roll into something that we can put into the user terminal as well.
Thanks, Ryan.
I think my views sort of pretty much echo Ryan's in that respect, that having multi-role terminals that can adapt between constellations and the applications that are running on them mean that it reduces the overall hardware costs, and the ability to have that interoperability between vendors without the sort of vendor lock-in. And those open standards are key. So yeah.
Thanks, Kevin. Mark?
Well, at least in the very near term, we as a company just want to execute on some of the early products and kind of contracts that we have that require digital IF, and I think we need to demonstrate value to our customers, in those products, and I really think it is something. I think I agree with some of the other panelists here. One of the big early adopters is the government. We actually see delivering those solutions to the government, and then expanding into the commercial market. I think that it, like you say, I think I said in the very early thing, I think you'll see just as you don't see too many 70 megahertz IFs anymore. You won't see any non-digital IFs, in 10 years. And so I think it'll be a ubiquitous thing that the group of people on the call here have a lot of company in supporting in the future.
Thanks, Mark.
So I will agree with everyone else. I'll say it a little differently, that the bold prediction that the future is digital, not analog, for the satellite industry. Not going really far out on a ledge on that, but digital IF is the first step in the digital transformation of satellite ground system, because once you do that, you can then have the capability to virtualize the back end, and then apply technologies like software-defined networking and SD-WANs, and drive greater automation into your operations. And so I don't think it's an if, I think it's a when, and I think that it's not too far out. I think you'll see implementations, in the next, easily within the next 2 years, if not the next year. As I mentioned earlier, it's already been adopted. You already see this happening in the EO market. with fairly wide adoption. I think for us, we have over 100 networks deployed in the EO market, using digital IF infrastructure to digitize and virtualize their infrastructure. So I think it's only a matter of time for the broadband satellite application, because they have to, as they move more into terrestrial IP transport. They're going to need to match the capability of the terrestrial telcos and integrate more seamlessly with them, and matching, having a software infrastructure the same as the telcos and the terrestrial telecom providers have, is going to be key to enable that integration. So whether that integration is at a 5G level or a MEF service application, having a similar infrastructure to the telco world is going to be critical. And so I think there's strong business reasons to drive to a digital IF infrastructure. And I think you'll just see a steady adoption of it, especially as more and more software-defined satellites are acquired and launched. I think just this year, if you look at the number of GEO satellites that are acquired and how many of them were software defined, I think it's almost all of them. And so the future is the more complex software defined satellites that are going to require a software based ground architecture.
Thanks, Stuart. It certainly sounds like this technology is the future. We need to stop looking backwards at our legacy systems and look towards our future systems, and perhaps we'll see some interoperability test bests across the globe then in the next couple of years, and bring other vendors in and really celebrate the benefits and making sure that those benefits are available to operators and users across the globe in this kind of bright future of complex systems, but accessible to all and bringing value to everyone. So I'd like to thank you all on behalf of GSOA and the community here in the SATCOMs domain, and let's see this future become realized at scale, not only for the Earth observation communities, but for all of the satellite infrastructure across the globe. So thank you very much, all of you, for participating today, and hope you have a great future together. Thank you.
Thank you, Paul.